Hey everybody, I know it's been a while since you've seen an update, but if this room is any indication of, ugh, you don't even want to look over it. Don't look over there. A lot of things have been happening. I've been working close to 30 hours a week on Kinograph on average, solid, for over 2 months now, and a lot of it has been tedious and frustrating, so I wasn't in the mood to give you updates. But we had a breakthrough. I wouldn't say it's a breakthrough because it wasn't a surprise or anything. Uh, it paid off. And I've got some new stuff to show you. The last thing that was in my way of having a design I had full confidence in was the gate, which was still 3D printed. I knew that we needed a metal gate eventually, and I'll explain why later. But it just wasn't, I kept putting it off, and I couldn't anymore. Also, I discovered the robotics kit that I'll show you in a little bit, and that caused me to go back and sort of reevaluate the overall frame design. I really wanted to lock everything in so that moving forward, I wouldn't have to cut a piece of plastic or create a new custom 3D printed part every time I wanted to test a new idea. I want to be able to swap ideas in and out really quickly with parts that are well made, and I don't have to design. So I want to take the design as much as possible off of me, give it to somebody else. Now I have a Lego set, or if you remember Constructs, I have, this kit of parts that I can put together that are standardized, and I can work around that. I can also just pull things off the frame. You can see it's a full, you may or may not be able to see, it's a full metal frame with holes in it right now, and that makes it real easy. I can just bolt something on. If I don't like it, I move it. If I don't like it, I take it off. I put another thing on. I don't have to keep drilling holes in plastic, and when that gets too filled with holes, take it off and make a new. You get what I'm saying. So, what is this kit of parts I'm talking about? This is the GoBuilda website, gobuilda.com. Let's just go to the homepage here. As you can see, it is for robotics. And the great thing about robotics designs is that they're made to be a rigid framed structure with parts that move a lot. That's exactly what a Kinograph is. So it works. As you can see here, they're modular, scalable, precise. All that means is that everything fits together with everything else. What that comes down to is an 8mm grid in both directions. So the spacing between the holes in both directions is 8mm, and every hole is 4mm. You will see holes that are larger. Those are made for bearings or large shafts to go through. There's also adapters, so if you have something that's not quite in this grid, you may be able to adapt to it. The whole point, though, is that, and here you can buy like bundles of the parts, which is kind of nice. The point, though, is that if I make a piece out, if I make a part out of these pieces, then you should be able to buy the same pieces and put it together yourself. Or if you modify that piece or make a totally custom piece, as long as you are building with an 8mm grid and 4mm holes, or that can adapt to that grid easily, then whatever you're making is guaranteed to fit on existing Kinograph designs or with existing. I do the English good. You know what I mean. Everything will be cross-compatible between users, between designs, between versions if we stick to this grid. So once I found GoBuilda, I went down a deep rabbit hole. I have hundreds of 3D printed parts laying around, and I have buckets of GoBuilda parts. I've spent hundreds, thousands of dollars probably on these parts trying to find the right combination. Spent a lot of time in CAD trying to come up with those different combinations. And so what we've come up with is basically using as much of GoBuilda out of the box as possible and 3D printing the glue where we need it to put those parts in the right position with one another. And it's working out great. So I'm excited today to show you how that has evolved into a brand new gate. You're going to see a little bit of the frame design, and we'll talk about that in later videos. This is going to be sort of like the developer version for people who, like me, want to continue to create new parts and mess with the design. The nice looking acrylic version will still exist. That's the plan for right now, and they will both be compatible with one another. They will use the same parts. The holes will, most importantly, be in the same place, and that makes it much easier for us to swap out whatever material you have available. So if you want to make this out of wood, you could make it out of wood, which I plan to do. I think it would be pretty cool. Anyway, there are lots of other little things that I could tell you about. I'm going to save them for further videos. The gist of this video is I never went anywhere. Cool stuff is happening, and we are closer than ever to a working Kinograph. Some of you may recognize this from a few years back. A community member brought this to me. It is the gate from a 35mm projector, and it's absolutely gorgeous. As you can see, I have committed great sins and cut into it here and there. This is back when I was using this as a temporary gate for Kinograph, just to see if I could get things working. But the reason I'm bringing it back is to talk about some design decisions I've made with the new gate design. And to do that, we need to understand what makes a good gate. First thing you need is a low friction, high durability surface for the film to run on top of. That should be smooth, it shouldn't damage the film, and it should not wear down over time. So metal's a great choice of any kind, really. You also need the same thing on the sides, so that when the film is passing through, if it rubs up against the side, which it should a little bit so that it doesn't go too far to either side, it also doesn't wear the material and it doesn't damage the film. So metal is also a good choice here. And as you can probably see, this is all one piece. It pops out, and you can place another one in there with a different aperture for different film formats if you want. So that's number two. Be able to change, or number three, I guess, be able to change different masks for different film formats. And then you need some sort of pressure system. Something that provides pressure on top of the film to keep it flat so that it doesn't flutter up and down and go in and out of focus when it's being projected or scanned. Metal is the perfect choice here, and for us to make custom metal parts for Kinograph is very expensive. For example, if I uploaded a file like this to a metalworking shop website, and it was about $500 if I wanted just one. That's because of all the setup that it takes for them to process that one file. After they do the setup, if you want more copies, the price goes down significantly. But if I ordered 20, it was still around $100 per piece, and that's not including all the rest of this stuff. So that's not very sustainable. It's not in line with our goals, and we would be dependent on that one custom design for someone else to make, requiring specialized machinery, etc. By going with a mass manufactured item like this robotics set, we're able to count on a supply chain a little more, and if we have to recreate some of the basic parts, we can with just a sheet of aluminum and a drill press, for example. We don't have to make all the holes, just the ones we use, right? So that is the goal. Can we use this robotics kit to create a gate that meets all the requirements that this one provides without being an antique? This design is more traditional, and it very much mimics the one that I just showed you. It has two sides of pressure plates. Those are pushing down, thanks to these springs, through this plate onto these rails. And these rails are, again, part of that robots kit. And on the rest of here, I can kind of, can't quite see it all because of the angle of this thing. Let me just pop this off. There's the rest of it. So let's, without thinking about the pressure rail, let's just show you how it works. This is the top. You just lay it right in and you're pretty much done. That's it. So then you would snap this down and you're ready to go. So there's still a little, well, actually in this case there's not a lot of play because that's nice. But if you wanted to make sure that there wasn't a lot of play, you would tighten this guy here. Whoops, wrong way. And what that's doing is pressing this bar onto the ballpoint pin springs, onto this floating slider. This, you can see it there. And that's just putting a very light amount of pressure on the film so that it lines up with this side. So you don't have to worry too much about lining things up, and it's real easy to just throw it in there. The pressure is really light. If you want to tighten the pressure a little bit, you can. So it is adjustable. The only disadvantage with this is you have to make a whole nother one for 16. And that's not so bad, really. It only takes 2 screws to take this out and put another one in, so no big deal. The other advantage to this, and let me grab a part real quick, is that in this configuration, as you saw, we're scanning side to side the whole width of the film. So we're getting the full perf sides and everything. If you wanted more pressure on the film to keep it really stable, if you had a really damaged piece of film, then you could swap out these two with just take these screws out and you could put in a full bar. You could put in a full bar here, and same with this. Let me show you how this works. You can just take this off. Lift up the plate. You would take out the 2 limit screws that are keeping this thing from falling off on both sides, and then you could put in a full bar here, put the plate back on, and since these are the same size, you have a full pressure bar on either side here too. So now you really have a replica of the original in that sense. But you can also take it out, as shown here, and get your full side to side. Or maybe you want to do a little bit of both, and maybe you want to put a full bar on this side, and you want the full perfs for stabilization in some software afterwards, so that you can see the holes and line them up, or whatever. So this does offer a little bit more robust stability, I think. One is cool, and this is solid. So I'm going to go with solid. It is way more 3D printing. You know, you're looking at a couple hours to print all these pieces, but you know, you print them once, and then you should be good. You also have to store it if you have several different gauges, whereas with the other one, it's just 2 pieces, and you never have to swap them out. So both will be available, and you can decide which ones you want. As far as masking goes, I still have to make masks for this, but you could either mask it from up here if you really wanted to, or you could make a drop-in mask down there as well. As it is right now, this will get you VistaVision plus some overlap on either side. Same with the black outline here. This design of the light housing is not up to date. So if I push it back to that black line, you'll get full VistaVision, which is the widest format of 35 that you'll encounter. There you go. This is half of one of the gate designs, and it's a little less traditional than the other one, but essentially it's made up of 4 metal parts and 2 3D printed parts. At its core, it's just a bottom rail and a top rail for the film to go through. So the film would pass through here. And this is always going to be stable underneath, and then this is loaded with a 3D printed spring. It's a little hard to see in action unless you move it around. So let's get a screwdriver, and you can see there's just enough there for some pressure to be on the film. So you can't change the pressure, but I don't think you really need to, because it's just enough, it's just the right amount. And if people have differing opinions on what the right amount is, you can just change the parameters of this ellipse, and then that would change the pressure on the film. It is put into place by going on the guide rails on these 2 holes. And the reason for that is, if we're imagining multiple gauges of film, so 35 all the way across here, but then 36, let's say, is going to go here, assuming that we line up the soundtrack in the same place. This side's going to have to move in a little bit for that 16, and this side's going to have to move in a lot of bit for that 16. Or if you want to center it for better light diffusion, same thing. You're going to have to move in this side, or you're going to have to move in that side. Either way, the sides have to move. So instead of switching out the whole plate, why not just move both sides of the gate? If you bring the bottom and the top with you, then that's all you need. So we've minimized the surface that the film is going to touch. It is flat, it's not curved, but it's also movable. So let's see what that looks like. This is the side that is static. You set this in place, and then the other one is going to have some pressure on the film in that direction so that we know it's always going to be lined up on this side. So then the question becomes, all right, so then do I have to fiddle with it here and get it just right? Well, no. There is a better way to do that. There is this tiny little, very easy to print mask. Well, it's a mask, but it's really also a stop. So by pressing this, it just press fits in there. These two sides will stop the slider, or this side of the gate, at this point in the metal. So when you just slide it right up until it stops, and you know you're in the right place. Now the other one has more room so that you can adjust it, and then it has a safety stop. You should definitely not be going any further than that, or something's wrong. So that side you will need to adjust, but this side you just kind of throw it on there. So let's put this on, and this is the side that goes in. Now this needs a little bit of refinement because it does take a little bit of, it sticks a little bit. But now that it's hit the stop, so I can tighten this, and now I can't move it anywhere. These are still left loose because I forgot to tighten them before the video, but there it is. So now I showed you the easy version first, because I think if you saw this first, you'd be like, what the heck am I looking at? Is this a transformer or a film scanner? But if you look at it like this, it's the same thing, right? But I've added these two surfaces. And this whole thing here is just to push the film in this direction so that it lines up with that side. So if you turn it around and we take a look at it, it's just an arm, two arms on a bar, two arms on a bar. These are springs taken from a ballpoint pen, and it's very, very light. Almost no resistance is needed to do that. So it's very easy on the film, and same thing, you just slide this on. Oh, I think I have it tightened, there we go. And you don't want to go all the way to the limit here, because as I said, that's a safety limit. So just back it off, or you could start there, either way. I don't know which, I'm going to do a little bit halfway in between. So once these are tightened, you won't see this kind of play. Some of you might be wondering, hey, that doesn't seem so great, but that should go away. So I need to improve, I need to make like a little threading assist thing over here, but basically you just thread this up. So you would pull back this part, oh, I went too close. So this does need some refinement, obviously, but yeah, just thread it through. And then once you're there, you can adjust the position of this, and that will determine how much pressure is being put on your film. So the closer I come in with this, the more this spring is engaged. You can see that there. But I should never be able to go beyond the perf line there. And that's what that 3D, the gray 3D part ensures there, okay? So I'm good there. I'm gonna back off the pressure just a little bit because I don't think I need that much. And that seems a little tight, so I'm gonna back off even a little bit more. That's a little bit better. One more backing off. Okay, I like that. That seems really good. Oh, we don't have the pressure we need, sorry. Am I in the right place here? This is why I need the threading assist. Yes, there we go. Okay, that seems better. Yes. So you're seeing a little bit of play here because I don't have it on rollers, but when it's being pulled straight, by rollers, you can see that that's going to be nice and solid all the way across. So with some adjustments here, I don't think it's going to be that bad. Those adjustments being, these rails will be solid, so you don't see this play. And you're also going to have sort of like a feed threading assist here. And then I'll find a way to make this gray part a little bit easier so that you line up at the right spot to do your threading, and you just start. Let's see if I can just make it easier. Maybe this is something you just get better at, you know. Well, let's even do it the easiest way. We go all the way out. I'm in on this side, and then if I just bring this side in, it should just line right up. Yep, I'm in, and you can see this is engaged right there. So I don't want to go all the way in, just a little bit. Done. And so you can imagine how easy it is. If I want to switch to 16, I just unthread this. I would take this out, switch in the 16 one, move that to its first spot, move this back in, rethread, I'm done. That's like a 15-second change. I hope that's exciting. If you're rolling your eyes and screaming at the sky with your fists in the air saying, why did he do this? Please let me know. I don't know everything. I would love to hear what you think about this stuff. If you're excited and saying, looking at the sky with your palms together and saying, thank God someone's come up with something I can actually use, also tell me, because that helps me too. We are rolling along over here. There is not going to be a stop in this momentum until it is done. I cannot promise any particular frequency of updates, because if I've got my head down and I'm doing stuff, I'm not going to stop to make updates just because. I'm going to give you an update when I have a really good update. So coming up next, you can look forward to turning on the lights, and then it's going to be reinstalling all of the electronics and motors that have already been tested and are working. I just need to make some quick adaptations to the laser perf detector rig, because it was built with 5mm instead of 4. And then we should have a machine up and running. At that point, it's software. We're close.